Hi everyone, I hope you're okay, and I hope that the videos we keep uploading are helping you out. On this video guys, I'll be tackling the 8th question from the preliminary exam which was written in the year of 2024 in the province of Eastern Cape. Please do expect a total number of 12 videos since the question paper had 12 questions in total, and that simply means each and every question will have its own video. And please guys, do take this seriously. I strongly believe that knowing how to tackle exam questions will give you an edge whenever you write your preliminary exam, and most importantly your final examination. So please guys, do share the video to your peers so that they may have the same edge as you, and please do help us grow the channel by just subscribing. Okay, first question guys, you're supposed to determine the derivative of f of x from first principle if f of x is just x squared minus 3. Okay, f of x is just equal to x squared minus 3. Now, we do have guys an equation we use to find the derivative from first principle. It simply says the derivative is just equal to limit as h approaches 0 of f of x plus h minus f of x all over h. We have limit as h approaches 0. How can you find f of x plus h? In the equation of f of x, whenever you come across x, please just substitute x plus h. So this simply means that our f of x plus h will simply be x plus h all squared minus 3. Are you together? You'll simply have x plus h all squared minus 3. We need to subtract f of x as well. That's just x squared minus 3 all over h. The whole entire purpose, guys, of finding the derivative from first principle is that whenever you come across h, we just need to substitute a 0. But right now we cannot do that because our h is at the denominator. If our denominator is equal to 0, the entire expression will simply be undefined. So the first thing we need to do, guys, is to just remove that h. That's the main objective before we substitute 0. Let's remove that h over there. How can we do so? By just simplifying our numerator. Okay, let's just remove brackets, guys, at our numerator. Whenever I multiply out these brackets, I'll end up having x squared plus 2xh plus h squared. I still have a minus 3. And then minus 1 multiplied by negative x by positive x squared, it's just negative x squared. Now, minus 1 multiplied by a negative 3, it's a positive 3. This is all divided by h. And I can see that, guys, this will subtract that one, and then the negative 3 will subtract a positive 3. So I'll basically be left with limit as h approaches 0 of 2xh plus h squared all over h. I can take out a common factor at the numerator, which is just h. I'll be left with 2x plus h all over h. The two h's, guys, can cancel one another, and then I'll be left with limit as h approaches 0 of 2x plus h. Are you together? And then the derivative, guys. Please note that whenever I'm substituting the value of 0 with h, I'm no longer writing this statement, because that statement kept on reminding me that I need to substitute 0 whenever I come across h. So I'll simply say 2x plus 0, and hence the derivative will just be equal to 2x. So the derivative with respect to x of f of x, the derivative is just equal to 2x. Okay, let's create room for us to write to answer the other questions actually. In the meantime, guys, I hope you are subscribing and sharing the video to your peers. Okay, we are supposed to determine the derivative of y with respect to x if y is equal to that. Since now, guys, we are not told to use first principle, there is a rule we can use. It simply says that if f of x is just equal to a times x to the power n. Therefore, the derivative of f of x will simply be n multiplied by a and then x to the power of n minus 1. You just have to take your exponent, multiply it to the base, and then subtract 1 from your exponent. That's how you find your derivative. This is how you find your derivative. Now, guys, please keep that in mind. But we cannot just find the derivative. Now, before you find the derivative, please make sure that the variable you are supposed to derive is not inside the bracket. The variable you are supposed to derive is not insert form. The variable you are supposed to derive is not at the denominator. Are you together? In our first question, guys, our variable is not insert form. Our variable is not inside the bracket. Our variable is not at the denominator. So we can simplify the derivative. Okay, we are told that y is equal to negative 3x squared plus 7x. Therefore, the derivative of y with respect to x will simply be negative 6x plus 7. You only write this notation, guys, if on the right hand side you will be writing your derivative. If on the right hand side, guys, I was not going to write my derivative, then I was not going to say dy over dx. I only write dy over dx if on the right hand side of my equal sign is my derivative. Are you together? So the derivative over here, guys, dy over dx is basically negative 6x plus 7. Okay, and then now we are given an expression over there. Oh man, we are given an expression over there. It simply says dx into the bracket. Now, dx into x cubed minus 5x squared over x cubed minus the square root of x. This notation, guys, simply says this capital letter D simply tells me that I should derive whatever that is inside the bracket with respect to x, which simply means I only derive terms which have x, and anything that does not have x is regarded as a constant. And please note that the derivative of a constant is always equal to 0. Are you together? Okay. Since I haven't found my derivative, I just need to keep on writing d of x. Now, remember that, guys, I said to you before I find the derivative, the variable I'm deriving should not be at the denominator. The variable I'm deriving should not be in set form as well. Are you together? So I need to deal with these two things first before I find my derivative. Okay, the x cubed, guys, divide both of these two terms. Are you together? So it's just x cubed divided by x cubed, and then minus 5x squared divided by x cubed minus there is a rule that, guys, we use whenever we change our set form into exponents. Now, please note that, guys, always the time the root of a number is always the denominator of your exponent. So this number over here is just x to the power 1 divided by 2. Now I don't have sets. Okay, one problem eliminated. I still write d of dx, guys. Now, x cubed divided by x cubed is 1. Then I'll have 5 into x to the power of negative 1. Why is that? Because if ever, guys, I'm dividing bases that are the same, I just have to take one base and then subtract my exponent. I'll say x to the power of 2 minus 3, and that will give me negative 1. Okay, and then I'll have minus x to the power half. So now I don't have the variable I want to derive at the denominator. The variable I want to derive is not in insert form. The variable I want to derive is not inside the bracket. So I can simply find the derivative. And please note that, guys, if my next statement is my derivative, I'm no longer writing this notation, because this notation, guys, reminds me that I still need to determine the derivative with respect to x. If the next statement is the derivative, I'm no longer writing d of x. Okay, I'm deriving with respect to x, and anything that does not have x is regarded as a constant. So the derivative of 1 is a constant, so that's just 0. And then if I derive negative 5x to the power of negative 1, I'll simply get a positive 5, and then the x will be negative 2. And then over here, I'll just have negative 1 over 2 to the power of negative half. This over here, guys, is equal to my derivative. But if I want to leave my answer with positive exponents, which is not necessarily required here, you can do so. So your final answer will simply be 5 over x squared minus 1 over 2. You can write it as x to the power half or the square root of x. It's just up to you, guys. So even if you left to answer here, you would have gotten the full marks, and even if you left to answer there, you would have gotten your full marks. So it didn't matter, guys, whether your exponents are positive or not. Okay, and then now we are told that suppose that g of x represents the rate of change of x, or of h rather. Calculate the largest value of g. Calculate the largest value of g. Okay, g of x, guys, is the rate of change. So g of x is basically the derivative of h. Are you together? So therefore, g of x is equal to negative 3x squared minus 6x. Are you together? So they want me to find the maximum value of g of x. The maximum value of g of x. How can I find the maximum? By finding the derivative of g of x and equating it to 0, solve x, and then go back and substitute that x value onto the equation of g of x. I'll simply find the derivative first. G prime of x is just going to be negative 6x minus 6. And then for me to find the largest value, I must take the derivative of g of x and equate it to 0, then solve x. That's just negative x minus 6 is equal to 0. Negative 6x is just equal to 6. Then x is equal to negative 1. So therefore, the largest value of g of x is just g of negative 1 squared minus 6 times 1. So the largest value over there, I'll simply have negative 3 plus 6, which is just positive 3. So the maximum value, largest value, is equal to 3. That's how, guys, you're supposed to tackle this question over there. So please do stay tuned and wait for more videos. Thank you.